Guys, I hope everybody's doing awesome, and I hope everybody had a chance to break out their Arduino and play around with some arrays and some code. Now, in the last tutorial, I alluded to the fact that there is another, perhaps more efficient way to write this program. And this is the same program, by the way, that we did last time. And we see here we have, there's some spaces and stuff, but 38 lines of code, okay? And some of you already know this. You already know about the for loop. But this time, for those who don't, or those who need a refresher, I am going to replace a lot of this code with a couple of for loops. And for loops and arrays, guys, are a match made in heaven. Now, the circuit is the same. Schematic is the same, so nothing's changed there. So we don't have to go over that again. If you want to go and look at the schematic and build the circuit, go back to the last video and do that. But we're going to get started, and we're going to go ahead and replace a bunch of lines of code with a few lines of code, and we're going to start here in setup. Now we're just going to leave this alone. We're still declaring an array with 5 elements, 5 bytes, and we're initializing it for pins 2, 3, 4, 5, and 6. Now here, last time, we used the pin mode function a bunch of times to set the pins as outputs. So this time, we're going to do things a little bit smarter. So I'm going to go ahead and I'm going to comment out all these lines of code. And then I'm going to come over here, and I'm going to add a space. And let's see. We want to use a for loop, so we start with the word for. And I'm going to use bytes again because they don't take up a lot of space. And we're not counting the 10,000. We're counting to 5. So, and yes, you can initialize a variable in a for loop, by the way. So we're going to say byte I equals 0. We're going to set it equal to 0. Semicolon. I needs to be less than, let's see, okay. We have 0, 1, 2, 3, 4, so that's 5 elements. Let me not hold the shift key down. And we're going to take I and increment it every single time we go through the loop. Now, customarily, when you're writing for loops, you use the letter I, and you don't have to use the letter I. You can call this anything you want to. You can call this really cool or something. It doesn't really matter, but we're going to stick with convention and call this, it's just an indexing counter variable. We're going to call it I, okay? So we need to have a curly brace when we get into the loop, and we're just going to go ahead and copy this. And we only need to write this once. And instead of the number 0, we need the index. We're going to put the variable I. So what this is going to do is each time the for loop's going to start at 0, start at the first element and iterate, and then set these pins, all 5 of them, to high. And this is just really 2 lousy lines of code instead of what here we had 5 lines of code. So we could see already we're saving a lot of space, a lot of code. Okay, so that's going to take care of making pins 2 through 6 outputs. So let's go over here and see what we could do with this. Here we use the digital write function and the delay function 349 times. Okay, that's a little much, maybe not quite that much, but we use it a lot. And I'm going to try to do a similar thing here. Let's go ahead and we're going to start by commenting all this out because we're not going to use this code. This is bloated code. All right, guys. And I'm going to come down here and I'm going to do another for loop. And I'm going to do another byte. I'm going to call this J because J is another standard variable name that you use in for loop. So if you have more than one for loop, I, J, K are all standards. Again, you could call it what you want to. And I could technically, I could call this I again, but because these variables have a scope that isn't global, and scope is kind of an advanced topic that we're going to tackle later. But to avoid confusion and to avoid making possible errors, I'm not going to use I again. This time I'm going to use J as my indexing counter variable. And that's perfectly legit. We're going to go ahead and set J equal to 0. J needs to be, let's see, less than 5 again. And then we need to increment J And by now, you guys should understand what a for loop does and how they work. So if you need to review, go back and review. But we're just going to go ahead and I need both of these lines of code here. Copy it. Paste it. Uncomment. And I'm going to replace the number 0 with the variable j. Let me make sure I learn how to type, because I'm not that good at it. Full disclosure, I'm not the best typist. Okay, so this is going to step through, and it's going to turn all the LEDs on with a half-second delay in between each. So we replaced here, I don't know how many, 2, 4, 6, 8, 10 lines of code with just 3 lines of code. Not a bad savings. So now we want to go ahead and we want to turn them off. So again, let's comment out all of our extra loaded code here. And let's use another for loop. BYTE byte. And I'm going to call this one K. IJK, standard traditional variables that people use with for loops and arrays, just as indexing. And this time we're turning them off. So we turn them all on, 0, 1, 2, 3, 4, and we want to turn them off in reverse order that we turn them on. So we need to be careful here. So instead of starting at 0, I want to start at 4. Okay, so we want LEDs 1 through 5 to light. And then once they light, they want to go off 5, 4, 3, 2, 1, etc. in a reverse order that they were lit. So we're going to start with K equals 4. And this time, we need to switch around our comparison operator. I'm going to do less than equal 0. And instead of incrementing, we're going to decrement. Again, the minus minus is just a decrement. I know most of the time you're used to seeing the plus plus, but you can also decrement too. I'm just going to copy and paste because, like I said, I'm not a good typist. And I'm going to replace this with the letter K. Delay, and that should do it. So let's go ahead and make sure that we didn't make any silly syntax errors. I'm not going to upload the code and run it. I'm just going to verify it first. This isn't a bad habit to get into, guys. Oh, see? Caught an error. Let's see what I did wrong here. I was not declared in this scope. See? Instead of using J, I wrote the letter I. Silly me. So let's go ahead and fix that. And let's try again. Okay, so the code compiled, which means that it's probably going to work. So let's go ahead and upload it. I'm going to click upload. And let's see how this works. Okay, here we go. And we see the LEDs coming on one at a time. And then they're going off one at a time. But wait a minute, something's wrong because they're not coming on again. It's supposed to repeat over and over again. They're supposed to come on one at a time and then go off one at a time and then repeat. What the heck? What kind of mistake could we have made that would actually cause that? So let's take a look, because something here is wrong. This is what's called a logical error. The code compiled. So the compiler's happy, but obviously we did something wrong because it's not working like we expect it to work. So this looks good. We're just making all the pins 2, 3, 4, 5, and 6 high using this for loop with the variable I. It's a byte, and it's 0 to 5, and we're 0 to 4 actually, and we are good here. So okay, let's step into the loop. Here again, we have another byte called J. We turn our LEDs on, and they're going on. So I have a feeling that this section of code is correct, and there's nothing wrong with it. Now here, we have this other third for loop, and we're using this for loop to turn them off. And let's see, we have another byte, a third byte we called K. We set it equal to 4. And K, as long as it's greater than or equal to 0, we keep decrementing it. But wait a minute, when K hits 0, what happens? Well, a byte can only store numbers from 0 to 255. Which means bytes can't go negative. What's happening is this byte K is actually going negative and it's causing the program to crash. That's why it's not looping through and going again. Wow, how can we fix that? What can we do? Let's see. I want to save space, so this is okay. This never goes below 0, neither does this, but this one does. Let's change that to an integer, because integers can be both positive and negative. Yeah, they take up more space, but you need to make sure, guys, that your data type fits your purpose and fits what you're doing, and you're not using the wrong data type. And I guess that's one of the lessons I wanted to drive home in this, is that if you don't use the right data type, you can get wrapped up in some stuff, and it can be, especially if you're new, hard to figure out exactly what's wrong. So here we're going to use an integer, and we're going to upload the code again. Let's click that. And okay, here we can see that they're turning on and off, and it's looping again, just like it did the first time. So that was the problem. We were just using the wrong data type. So here we go. We replaced a whole bunch of code, and I'm going to go ahead, guys, and I'm going to delete all these comments just so you can see how many lines of code we saved. And I'm going to leave the comments that were there by default, like this one and this one. Okay, because they come when you open up the IDE. We took this down to 27 lines of code, and that includes a lot of extra white space. So we have here, really, we get rid of all the spaces, and we still leave those default comments intact. We have only 21 lines of code. Okay, 2 of which are comments. So we really were able to scrunch this program down just by pairing a for loop, or 3 for loops in this instance, with arrays. That's the lesson, guys. We're going to do some more stuff with arrays before we get into collecting data with sensors, because you can collect hundreds or even thousands of data points, say with a sensor, if you're measuring the temperature even if you're measuring every few hours or every hour, and you're doing that for days and weeks on end, you're going to collect a lot of data points. And to have to type digital write, blah, 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 over and over again, it's just so cumbersome. So I wanted to get the for loop and the array pairing out of the way before we got into using arrays to work with sensors and collect data. Because again, when you are working with sensors, depending on what you're sensing and what your sampling interval is, you can rack up hundreds or even thousands of data points pretty quickly, and you're going to need to use arrays with for loops for that. So until next time, guys, go out, give this a try, practice, and I'll see you next time.